Hello everyone, welcome back to my channel, and today we are going to solve a very important question of Leetcode, which is going to be remove outermost parentheses. So in this problem we are given a valid parenthesis string that consists of multiple primitive parentheses like this. Our task is to remove the outermost parenthesis from each primitive string and return the final result. So now let's see the intuition. So in order to solve this problem, we want a counter, which is going to be our count, and a result where we're going to store the output, right? So we use a counter to keep the track of the depth of the parentheses. For example, think of it like entering and leaving a room. For example, if you're going to get like this close opening bracket, so it means like going inside, means increasing the depth, right? Means we are increasing the depth. Or if we're going to encounter something like this, the closing bracket means we are coming out, means decreasing the depth. So whenever we're gonna encountering the opening bracket, so we're going to increment our count by 1, and whenever we're going to encounter the closing bracket, we're going to decrement our count by 1, right? So first of all we're going to do this. We're going to increment or decrement our count, and afterwards we're going to analyze the pattern, and then we're going to write the code. So first of all, now let's see how we're going to do this. So as I have told you, whenever we're going to encounter the opening bracket, we're going to increment our count by 1. So I'm going to write over here 1, and again we get the opening bracket, we're going to increment our count by 1, and now we're going to get 2, and now we get the closing bracket. So if we're going to get the closing bracket, we're going to decrement our count by 1. So it will going to be like this 1, right? And now again we get the opening bracket, we're going to increment it by 1, so we're going to get again 2. We're gonna get the again closing bracket, so we get a 1, closing bracket decremented by 1, we're gonna get 0, right? And then again the opening bracket, so our the value of count is going to be 1, again we get the opening bracket 2, and then we get a closing bracket 1, and then we're gonna get the closing bracket 0. Now look at carefully. What we are going to do is that whenever whenever the value of count is equals to 2, or if it is greater than 1, we can say, like in this case, if our count the value of count is 2, we are basically encountering the opening bracket, and that bracket is the valid one. We actually want that, right? Because it is inside the bracket, it is not the outermost bracket, right? Now look at here also, if the value of count is 2, we are basically encountering the opening bracket and a valid one. Again, if you're going to see value of 2, we are basically encountering the opening bracket, right? And one more thing that I want to make sure over here is that if you're going to see the value of count is greater than 0, if it is greater than 0 means 1, and that bracket is the closing bracket. So whenever we get the closing bracket, the value of count is basically greater than 0, means it is 1. Here also we get the closing bracket, the value of count is greater than 0, means it is 1. Again, if you're going to see here, you're going to see a closing bracket, the value of count is greater than 1, right? So here we come to know that whenever we get a we get an opening bracket, okay, whenever we get an opening bracket, the value of count, I'm going to write over here, count is actually greater than 1, right? And whenever there is a close bracket, whenever we're going to encounter the close bracket, the value of count is actually greater than 0, right? So this is what the cases we get, right? So according to this, we're going to add them all the bracket inside our result, and this is how we're going to get the valid parentheses, and that's going to be our output, right? So basically what we are doing is that we use a counter to track the depth of parentheses. Whenever we encounter an opening bracket, we increase the depth. When we encounter a closing bracket, we decrease the depth. We only add bracket to the result when the depth is greater than 1 while opening and greater than 0 while closing, right? So this way we skip the outermost bracket of every primitive string, right? So now let's see the coding. Okay, so basically we want a result where we're going to store our final output. So I'm going to take a result and we want to count, so that we're going to keep the depth of our parentheses. And yeah, let's iterate this for I in, I'm going to write over here S, right? So that we're going to get the brackets one by one. And if our bracket is equals to closing bracket, or we can say like opening bracket, if we're going to encountering the opening bracket, we know that we're going to increment our count by 1. So we're going to write over here count plus equals to 1. And also we have condition, right? We have this condition that if count is going to be greater than 1, so we're going to add this inside our result, right? So I'm going to add this result plus equals to I. We're going to add that bracket inside our result, right? And now in else case, if we're gonna get the closing bracket, so we know that we need to decrement our count by 1. So I'm gonna write over here minus equals to 1. And also we have a condition, as I have told you, this condition, right? It should be greater than 0. So if count is greater than 0, so in that case what we're going to do, we're going to add inside of a result. So I'm going to write over here result plus equals to I, right? So this is how we're going to do this, and at the end we're going to return our result. So I'm going to write over here return result, right? And now let's run this. Accepted, and now let's submit this. So the time complexity of this algorithm is bigger of n, or also the space complexity is bigger of n, and here it is submitted. And yeah, that's it. That's all for today.